Hello everyone, my name is Avant Mehta and welcome to my video of ABE425 Lab 4, where today we're going to have a look at the step response circuit. First, let's have a look at the schematic on the top left of your screen. Here I have my input voltage and my switch, both of which I will control with my Arduino. Then I have a resistor of 100 kilo ohms and a capacitor of 10 microfarads, which is connected to my common ground with the Arduino. Here I have my pin A0, which measures my voltage across my capacitor. And that will be displayed on this graph over here. And now I'm ready to start collecting 100 samples of data. So I'll hit collect data, and this takes about 3 seconds for 100 samples. And here I have my max voltage is 4.668 volts, which is not very close to my nominal max voltage of 5 volts. And also I've not flatlined on my graph either. So I'm going to increase the number of samples to 300 and collect data. And while that's happening, I'll show you my actual circuit and how it corresponds to my schematic. So here I have my resistor, which is connected in series to my capacitor. Here I have my yellow wire, which is the output of my Arduino, which acts as an input voltage into this circuit on my breadboard. Here I have my orange wire, which measures my voltage across my capacitor into pin A0. And finally, I have my black wire, which acts as the common ground wire between my Arduino and my left side of my small breadboard. Finally, I made sure to connect my capacitor the correct direction so it doesn't pop out and release noxious gases into my apartment. So that being said, my circuit correctly matches the schematic. So let's have a look at the app again. Over here, I've taken 300 samples of data in 8.3 seconds. And my max voltage is 4.99 volts, which is very close to my nominal of 5, and we have flatlined. So now I can change the value of my time t to be equal to 1 second. So I can find out what the voltage was at time t equals 1 second, and that was 3.363 volts. The theoretical value for that is 3.15 volts, and that was calculated by using the formula theoretical voltage equals Un multiplied by 1 minus e to the negative t divided by tau, where tau was calculated using my resistance and my capacitance as given in the circuit over here from the nominal values. Finally, I have my error, which is 0.2082 volts, and that is simply the actual voltage minus the theoretical voltage. And in this case, I think 0.2 volts is fairly accurate for the purpose of this lab. Now let's have a look into the characteristics of tau. We're going to perform a unit analysis on tau using two different equations in this lab. First, we have our primary equation, and that is Un equals tau multiplied by U naught dot plus U naught. So now I can write down the units for each of these expressions, and on the left side we have simply volts. For U naught, we have volts again. And that means to find out the units of tau, we must set the value of the units of the middle bracket to also be equal to volts. We know that the unit of U naught dot must be volts per second because it is a time derivative of voltage. And now we can see from this middle bracket that the units for tau must be equal to second for the second to cancel in both the numerator and the denominator for the middle bracket to be equal to volts. Hence, from this equation, the unit of tau is going to be equal to seconds. Now we have our second equation, and that's tau equals RC, or tau equals resistance multiplied by capacitance. And what we're going to do over here is replace the values of R and C with other expressions for them using Ohm's law, which is V equals IR, and the equation for capacitance, which is Q equals CV, which in this case our V is going to be equal to U naught. So now we have tau equals V divided by I multiplied by Q divided by U naught. Now we can write down the units for each of these values. V is measured in volts, I is current, which is measured in coulombs per second, Q is charge measured in coulombs, and U naught is measured in volts, Now we can simplify these units by cancelling volts from both the top and the bottom, and also coulombs from the top and the bottom. And that leaves us with 1 divided by 1 over seconds, which simplifies down to being seconds. And thus we've proven from both these equations that the units for tau will indeed be seconds, and this also matches what we've learned. So that's what I have for you in today's video, and as always, thank you so much for watching.